Good afternoon, everybody. I think we can start. It's Midi from the Center for Extramural Studies. Today you've got Gosia Lipinska speaking. So can I hand over to you, please, Gosia?
Yes, certainly. Hello, everybody. It's good to be here and be part of this lecture series. And I hope you enjoyed it yesterday and will continue to do so for the rest of the week. I'm situated in the Department of Psychology, and I'm particularly interested in how sleep overlaps with psychological functions. So we've been learning over the past couple of decades about sleep's role in cognitive and in emotional functions, and that's really what I'm here to chat to you about today. And you know, you would have had a bit of an introduction to sleep and all the physiology from Dale yesterday. And sleep is indeed a very interesting state. It's a state of being unconscious on, you know, once in every 24 hours, there's this period of being unconscious. But it really sort of brings to mind what is consciousness? You know, if sleep is a state of being unconscious, what is consciousness, and why do we sleep? And then what I also want to talk about is these psychological functions that we understand are related to sleep. And I'll be talking to you about that from the point of view of healthy individuals, because in psychopathology or when individuals have other conditions, we know that sleep is often complicated or disrupted, and then this has implications for functioning as well. So I'm not going to cover that too much in this particular lecture, but it is also something I'm quite interested in. So consciousness is a sort of interesting state. We can think of consciousness on quite a few levels. The one is simply being awake. From that point of view, we may think, well, if consciousness is being awake, then are, for example, animals conscious? And is it a little bit more than that? We know, for example, that we have experiences, we have feelings, we have emotions, and we have those when we are awake. They have a quality to them. And then there's also being self-conscious, which is being aware of these experiences. And all of this very loosely we may understand as consciousness, as an experience, as feeling, as sentience, and then sort of towards the end of that trajectory being self-conscious. And then, you know, as we start to think about how this may change, there may be altered states of consciousness, and these may be where you are not necessarily aware of your environment, either through drugs or through meditation or through hypnosis. There's an altered state, a way in which you may be focused in a different way, or through daydreaming. And sleep is one very common and profound altered state of consciousness, and it's in fact a state of being unconscious. And the curious thing about it is that it happens every single day, and it's also marked by other interesting phenomena such as hallucinating, which is you know, in the form of dreams. We have physiological and behavioral descriptions or definitions of sleep, which Dale may have gone into some greater detail. We know that it's the thing about it, even though it's in an unconscious state, it's reversible. After a period of sleep, you wake up and then you continue with your day. It's marked by very specific brain patterns, which I'm going to describe just very briefly, mostly in aid of setting the terrain for how we can understand some of the psychological processes that happen. It's also marked by these specific eye movements in some stages of sleep, and also decreased muscle tone. And we know that there's sleep pressure. So the longer you go without sleep, the more pressure there is to sleep. From a behavioral point of view, typically humans and other animals that sleep are non-responsive to external stimuli, and that's part of the unconsciousness of being asleep. And most, including humans, most animals adopt a typical posture. In humans, it's the supine position, in other words, lying down, and it's often, because it's quite a vulnerable state, it's in a sheltered site, because you're not aware, you can't ward off, at least before the times when we lived sort of in houses and things like that. You would be in the open environment and vulnerable to predators, for example. And it happens at least once in a 24-hour cycle. Now, the curious thing about sleep is that we spend such a huge part of our lives in sleep, and it's found across different classes of species and animals, in mammals. Aquatic animals such as dolphins and fish have sleep, birds, reptiles, and they're even rest and activity cycles in very, very basic animals such as worms, snails, things like that. And there's been a tremendous amount of research in studying those animals as well. And so since it seems to be so pervasive across different animals, and that we spend such a large period of time, it must be very, very important, and something that's arisen and been maintained through evolution must have a really good reason. What is the reason? Well, that is still a matter of debate. There's certainly some immune functions that happen in sleep that are very important. They're kind of restorative functions. That's been the one sort of argument for sleep. But there's also quite a few strands of research which posit that sleep's very important for brain health and for brain processes such as thinking and feeling, so for cognition and emotional functioning. And you may not be strangers to this, but I'm going to just refresh this to lay the groundwork for what I'll say next about psychological functions. But sleep is made up of 4 distinct stages of non-REM sleep, and then you have REM sleep as well. These 4 stages of non-REM sleep essentially represent a deepening of sleep from waking through to what we call stage 1, which is really the transition to sleep, and then sort of a deeper level of sleep being stage 2, and stages 3 and 4 being considered your deep or slow wave or restorative sleep. That's the stage that's really important for when you wake up in the morning and you have that feeling of being refreshed. REM sleep, on the other hand, has its own distinct electrophysiology and is quite different from the other stages. And I'll talk more about that in a second, but there's the cyclical nature of these stages. So whereas in the first half of the night, you will cycle through all of these stages, so stages 1 to 4 of non-REM sleep followed by REM sleep, the cycles are comprised by a much greater percentage of slow wave sleep, so of your deep sleep. So you go through a cycle, but much of the time is in slow wave sleep. And then the second half of the night, that reverses to some extent, where you're spending quite a lot of time in REM sleep. So you'll see that the cycles are much shallower. There isn't nearly as much deep sleep. Mostly you'll be spending time, maybe a little bit of stage 3, but mostly stage 2, and then these longer periods of REM sleep. Electrophysiologically, this is more or less what it looks like. You have these, when you're awake, the EEG is very small and sort of spindly like this. And then as you fall asleep, it sort of relaxes. And in stage 2, you have these kind of sharp waves called K complexes. You have things called spindles, which are really regular waves. And then stage 3 and 4 is marked by these sort of big delta waves, which we call the slow waves. And some of these electrophysiological features are important because we see them featuring in the processing of cognitive and emotional information. REM sleep, as I mentioned, is electrophysiologically quite different from the other stages. You have, this is the EEG at the bottom. So that's, and by EEG, maybe let me backtrack. You guys may have been exposed to this term, but it's the electroencephalograph, which is essentially the electricity that's coming off your scalp, generated by neurons firing. Now, primarily it's picking up the firing of neurons which are perpendicular to the surface of the scalp so that you can get the signal coming through. And of course, it's able to collect the signal coming from neurons that are closest to the scalp, and the least signal is picked up from those deepest in the brain. So it's a very sort of, from a localization, very generalized way of understanding sleep, but it gives us an overview of the parts of the brain that are firing very loosely, but it has very good temporal resolution. So in other words, when information is being processed is very, very precise using this technique. And it's very useful for understanding cognitive functions, as we'll see later. So here we've got our REM EEG at the bottom here. Here is our EMG, in other words, muscle tone. And what happens in REM sleep is that your muscle tone goes down. It's often not very clearly visualized, but you can see it's a bit darker here on the left-hand side. And then we've got our eye movements, which are these spikes that you see across the eye channels. And this means that your eyes are moving from side to side rapidly. And this is what gives REM sleep, or rapid eye movement sleep, its name. And just going back, this is the alternating cycle with lots of these slow waves in the first half and a lot more REM in the second half of the night. And a lot of the sleep research we do in our lab is precisely looking at the electrophysiological signals that come from our participants that are in our research studies. So we'd do a whole setup and participants would sleep in the lab, and we'd look at 8 hours of recording, which you can imagine is quite a lot of data. So now getting to the really interesting stuff, now that we've laid the groundwork. So what's one of the big functions of sleep, as I mentioned, that's come to the fore, is for brain health and cognitive and emotional functioning. We know, early on when we started looking at cognitive functions, it was clear that if you sleep deprived, you're just not thinking very clearly, and that was sort of very loosely outlined. And so we knew that your attention wasn't very good. Individuals slowed down, so their reaction time wasn't very fast. And there's some actually very interesting studies before I get into sort of the memory and the emotional stuff, which is really what I'd like to talk to you about. But, in that kind of earlier research, we, for example, found out that being sleep deprived is more dangerous actually than drinking and driving. So your reaction times, somebody who has had 3 beers versus somebody who sleeps 6 out of 8 hours, the person who slept 6 out of 8 hours of their typical sleep period is slower in their reaction time than a person who's just downed 3 beers. So that's, shows you something about the importance of sleep for reaction time, for responding quickly, and should make you consider driving when you are sleep deprived quite carefully. So that was, from our everyday experience, that seems pretty obvious. But more recently, and when I say recently, it's not that recent, it's perhaps in the last 20 years, we've been finding out a lot about the importance of sleep for memory. And this is really, I think, very, very fascinating stuff, because there's been a lot of very detailed research which has described how sleep actually consolidates our memory and how it's important for helping us hold onto information and integrate new information. And it seems that deep sleep, so in other words, slow wave sleep, has one very important role, and REM sleep has another important role, and they may in fact be complementary. There's a fair amount of disagreement about some aspects of this research, but this is a sort of a summary maybe of what we know at the moment. So what slow wave sleep seems to do is that there's a process where these delta waves, as I described them to you, these large waves, are generated by the front parts of your brain. And in the center of your brain, there's a sort of small ripple called the hippocampus, which is very important for initially encoding, laying down those memories, and later for connecting them to larger networks of information. And it seems that sleep does this connecting job, and particularly slow wave sleep. So when these large delta waves are generated by the frontal lobes, essentially, it forces these spindles, which are generated by the thalamus, to coordinate with rapid firing from the hippocampus. And we think that information is transferred to the rest of the brain through this synchronized firing. And that's a little bit what we term active system consolidation. So I'll describe that in a second. So that's the one thing that slow wave sleep seems to do. You have this pattern of firing which synchronizes between areas in the brain which are responsible for memory, being associated with other neocortical areas. So in other words, the gray matter on the outside of the brain, where a lot of information is all connected up together, and that's really what we understand as memory. And so those areas synchronizing and information essentially being transferred from hippocampal networks to the neocortex. This has certain important implications. For example, that the hippocampus is then refreshed or free to take on new information the next day. And after a night of sleep deprivation, for several reasons, but this is probably one of them, it's very hard to hang on to anything. It seems that your brain is so fuzzy, and this may be a reason why you have that experience, is simply because your hippocampus has not undergone the process where the information that was originally encoded there has been transferred to other areas of the brain. And then, so those are the sort of primary functions that slow wave sleep or deep sleep has for memory. But we also know that REM sleep is important. So whereas slow wave sleep seems to transfer information from the hippocampus to other areas, REM sleep has a very different function. Before I get to that, actually, I wanted to mention one other function that slow wave sleep has. So there's been two study groups, primarily from Europe, but also from the States, and the one has looked at this transfer of information, and another group has looked at a very different concept, and that's the concept of depotentiation. And what this group has shown is that globally, during slow wave sleep, there is a sort of decrease in synaptic strength between neurons. So there's a general dampening down, whereas during waking, synapses are potentiated through experiences, things connect together. During sleep, there's a depotentiation. And the overall net result of that is that synapses that aren't strongly connected together are simply eliminated. And so this may be one kind of explanation behind why we remember important stuff but forget unimportant stuff. Like, for example, if you were to think back to the 5th of February last year, unless it was an emotionally significant event which may have resulted in these strong synapses, for example, like your birthday, you probably won't remember what you had for breakfast that day or what you wore or any of those kinds of details. They have simply been eliminated on the basis that they were not strongly potentiated in the first place. So there are these two functions of slow wave sleep. And then thinking about REM sleep, whereas in slow wave sleep we have this kind of reorganization of information and strengthening of the relevant information, it seems that REM sleep may have something to do with keeping that information there. So we know that there's this process of gene expression during this stage of sleep, which releases certain chemicals that are responsible for long-term potentiation, which is essentially ensuring that that synapse is maintained and stays there for a long time. And so that the maintenance of those connections seems to be performed by REM sleep. So this is just a graphic to kind of bring that home. Whereas in slow wave sleep, we have this active system consolidation where if we have a new piece of information, which is represented by these dots, it's then transferred to neocortical areas and integrated into previous existing knowledge. And you can see that these, it's still a little bit, you know, it's there. The connection is there. In REM sleep, we don't have this dialogue that I mentioned before between, say, hippocampal regions and neocortical regions, but instead you have localized strengthening of connections. And that's your synaptic consolidation. And this is just another depiction of that again, of this coordinated firing of neurons, neocortex to thalamic spindles and hippocampal sharp wave ripples. And then in REM sleep, we rather have this these immediate early genes which are expressed, which lead to long-term potentiation. Okay, so that more or less describes some of our understanding about the relationship between sleep and the integration of new memories, the strengthening of new memories into existing knowledge. And primarily a lot of that research has been done on rats, also on humans through behavioral studies. We've done several behavioral studies like that to show that in psychiatric disorders such as post-traumatic stress disorder, where we know that sleep is disrupted, we see that memory processes related to sleep-dependent consolidation are also disrupted. And that's some of the earlier sort of research work that I was involved with. And now, you know, from your everyday experience, you may have sort of seen that when you're sleep deprived, you can't remember very well. But a lot of individuals say that, you know, the big thing that happens when you're sleep deprived is that you quite emotionally unhinged, emotionally labile. Small things can be become a huge thing. It's quite difficult to sort of feel like you can make it through the day without flying off the handle. that sort of thing. Although our understanding of the relationship between sleep and emotional functioning isn't as well developed, we are starting to sort of investigate this field as well from a number of different points of view. The one point of view is looking at what happens not only to sort of memory in general, and typically those studies that I've talked about are neutral declarative memory. So in other words, memory that you can bring consciously to mind about things, about events, about information, and that is not valent. So it's not positive, it's not negative, it doesn't carry emotional charge. But we've now started to look at how sleep interacts with emotional material as well. And then, and that's also in the realm of sort of declarative memory. You think about something, you can relate in an emotional piece of information. But we've also looked at how sleep may modulate less conscious processes, like, for example, conditioning. And conditioning is a sort of, it also is a kind of memory system, but it's not conscious. It's when something, a stimuli gets paired with another event, which then causes you to react in a certain way. The classic Pavlovian sort of paradigm is that when the dog hears the bell and then is presented with dinner over successive days or weeks, the sound of the bell will result in the dog salivating because they are expecting their dinner, and they can't help whether they salivate or not. It's a conditioned response. So there's some information about how fear works or consolidates conditioned responses, and then also about how sleep is involved in emotion regulation. So just checking my time here. So what we know from research, and this hasn't been completely uncontroversial, but that sleep seems to be over and above this effect that it has on neutral declarative memory, or sort of like our tell a story about something that happened type memory. It seems to consolidate emotional experiences and emotional information more so than neutral information. And by consolidate, I mean more than waking. So whereas you were to remember an emotional piece of information and a neutral piece of information while awake, it seems to be that the difference between the two, because we always remember information better than neutral information, that effect seems to be much stronger over a period of sleep. In our lab, we actually, because there's quite a lot of contradicting information, we did a meta-analysis, which is a summary of all the data, and we found that that was true, but only under very specific conditions, actually, and that was when these tasks were such that they probably employed hippocampal networks. So remember, the hippocampus is the part of the brain that's responsible for memory formation. So it seems like for those kinds of memories, kind of conscious emotional memories, that's where sleep, and probably for sort of similar reasons as we've described, we need our REM sleep and our slow wave sleep. It seems to consolidate those kinds of emotional memories more so than neutral memories after sleep rather than waking. There's also other information on sort of the memory consolidation aspect of emotional memory. And we know that if you're sleep deprived, you tend to not treat all information equally. You are biased towards negatively valenced information. So you tend to remember and consolidate that information more if you are sleep deprived. So one sort of hypothesis, and something we've been looking at in our lab and continue to do so, is that sleep's very important, not actually so much for consolidating emotional memory over neutral memory, but perhaps sleep's really important for ensuring that we have a kind of balanced palette of information, as it were, so that we're not favoring only positive information, in other words, a kind of manic outlook towards life, or negative information, a kind of depressive outlook on life, rather that we have a sort of balanced palette of information in the morning. And I think that's something that hopefully we'd be able to talk about a little bit more once we have that information. But I think that's probably more sort of true to everyday lived experience, that you wake up feeling fresh, kind of able to take on life's challenges, and part of that is an emotional kind of balance. From a fear conditioning point of view, we know that, for example, if you have a bad experience, so say a profoundly traumatic experience, sometimes some aspects of that experience, so for example, you're in a very bad car crash, and it was a blue Golf that caused the accident, you may then, every time you see a blue Golf, so not just that particular blue Golf that caused the accident, but any blue Golf, and perhaps any Golf cars at all, may cause you to have a physiological reaction. So that's a conditioned response. And when over time, when you learn and you see many blue Golfs and they don't all crash into you, that kind of physiological response sort of ameliorates, it comes down, and that's what we call extinction. It's very important because otherwise you'd live in the trauma of it, you know, for a protracted period of time, and which is in fact what post-traumatic stress disorder is. And we know that sleep is really important to bring down, so in other words, to facilitate extinction, and also to help us understand that it's not blue Golfs, it's not any blue Golfs, and so for that kind of generalization of the fear extinction from one stimulus to another. And we know that REM sleep, in fact, is a stage that seems to be associated with that fear extinction. And then, you know, I think from everyday experience, I think some of the most interesting research is on emotion regulation. And here we know that under conditions of sleep deprivation, so typically when you're going through your everyday life and you're faced with emotional stimuli, you will have activation in limbic areas, so areas that we typically understand are responsible for emotional processes, for example, like the amygdala. And then you'll also have some inhibitory control from the frontal lobes and frontal areas, which kind of modulate those responses so that your emotion is kind of interpreted and understood in a concept, in a particular context, and you can respond, you know, think about things, that sort of thing. Now, under conditions of sleep deprivation, those frontal areas are not able to inhibit limbic responses to the same degree as they are when you have slept normally. So there's a loss of connectivity between those frontal areas and between limbic areas, in particular areas such as the amygdala, which are very sort of in conditions where someone is fearful, there's a lot of activation of the amygdala. So that these neurobiological findings kind of support our experience of when something happens when you are sleep deprived, you're much more likely to react with stronger emotion, to not be able to modulate your response or think things through. And that's because literally the frontal lobes are to some degree disconnected from your limbic system. And what we see is also that there's more connectivity between the locus ceruleus, so an area that produces noradrenaline and is involved in the fight and flight response, and the amygdala. And so that kind of instinctual responsivity is actually strengthened. We also know that when you are sleep deprived, so that's kind of about negative stimuli, but we know that when individuals are presented with rewarding stimuli, reactions may be blunted in some cases. There's also some contradicting evidence. And in other cases, there may be also a lack of inhibitory control. And this is relevant for something like substance use disorders, when individuals struggles to modulate their responsiveness to reward, essentially, the drug or alcohol or that kind of thing. So all of this has been, I suppose, to this point, fairly cognitive and sort of basic processes. But we also know that dreaming is something, or very important thing, that happens during sleep and may play a role in modulating both cognitive and emotional processes. It's an experiential phenomena that happens every night. It's more frequent in REM sleep, but doesn't only occur in REM sleep. REM dreams, we know, are more bizarre, more emotionally toned, and there are more reports of dreaming in REM sleep. And it's also during this period that the limbic system, so areas that we know that are responsible for emotional processing, are very active. So the amygdala, the anterior cingulate, hippocampus, and all of that. So we can just from that information, we can think, well, a REM sleep must be in some way important for modulating emotion. And this, it happens, we know that humans dream, but dreaming is probably very widespread in other animals as well. So for example, we can imagine that this dog is dreaming. In fact, by his actions, it's probably not entirely normal, because during REM sleep, muscle tone is reduced, so we don't act out our dreams. And in fact, there's some conditions where that mechanism fails, and it's called REM behavior disorder, which is what this dog may have. But what it does allow us to infer is that dreaming is probably quite ubiquitous amongst many species, and therefore also important for something. And I think Mark will go into a lot more thinking about dreaming and the role that it has. We've been starting to think about a variety of projects and how to conceptualize this, and certainly Mark has been thinking about this for a long period of time and will elaborate. But just to sort of start things off and start some thinking in that area, Freud first really took dreams seriously and thought about dreams as motivated and as a kind of unconscious wish fulfillment. So that you were generating or some aspect of yourself that had meaning, had motivation, was being represented in your dreams. Then sort of thinking moved more to a sort of computer analogy process sort of model, where we thought about dreams as simply an epiphenomena of brain processes. They're generated because information is being processed, and this includes the activation of, the limbic regions. And so simply we're processing that kind of information as a computer would file away, defrag the drive, file things away neatly into the spaces that they need to occupy. But we've gone back to a more a kind of thinking where dreaming is seen as a process that is quite motivated. Dreams are full of emotion and experiences that seem to be relevant to the kinds of everyday things that we're dealing with in our lives. And humans aren't just actually computers, we are also emotional creatures. And so perhaps the purpose of dreaming is to deal with and somehow understand emotional problems that we may have in our lives. So that's just a little tidbit going forward to what will be spoken about later in this series. So I see there's a question from Maddie here. She says, very interesting. As one ages, one often sleeps for a shorter time, say 5 to 6 hours instead of 7 to 8 hours. Could poorer recent memory among many seniors be related to less REM sleep? Yes, it has been postulated, and there is evidence to say that not only less REM sleep, certainly less slow wave sleep as well, which we know older people do have less slow wave sleep, that this seems to be related to poorer memory functioning, and those do seem to be intimately linked. It is normal though as well. On the other side, there is an extent to which, if you are sleeping very poorly, it doesn't cause things like Alzheimer's or dementia, but it may be a risk factor for it. Just like, if you are overweight and have hypertension, it doesn't mean you will have a stroke or cardiac disease, but it is a risk factor for that as well. Glenn.
Hello. Sleeping pills, how do they affect this whole pattern of sleep?
Yeah, so that's a very, very good question. So sleeping pills, there's two broad categories of sleeping pills. And these days, many different things are used as sleeping pills. So, but traditional sleeping pills kind of come in two categories. One is the benzodiazepines, which are kind of an older class of drugs. And then you get your new Z, they're not really new anymore, but your Z class drugs like zolpidem and all of that. Benzodiazepines, while they do help you sleep and are really good for sort of symptomatic relief, in the long term have been associated with cognitive decline, and are also seen kind of as a risk factor for poor cognition in later life. So are really not a drug that one wants to be taking in the long term. Z-class drugs initially were thought to avoid a lot of these kinds of difficulties, but neuro research is also showing that they're also not that great. So both of those drugs are really important and very good for symptomatic relief in periods of great difficulty or crisis. Certainly, they can be life-saving in those contexts, but as a long-term solution to sleep difficulties, have quite significant and detrimental side effects.
It's Robert here.
Hello, Robert.
When you have afternoon naps, does REM kick in?
Yes, you can have the full spectrum of sleep stages during an afternoon nap. It doesn't always happen. Some people will sleep more to a more shallow degree, which means that you'll have less slow wave sleep, less REM sleep, but you certainly can have REM sleep and afternoon naps as well. Nolene.
Hi, hello, thank you. Sorry, I just wanted to ask, I know that benzos are considered sleeping tablets, but do they create sort of the EEG picture of sleep, or do they actually put someone into a natural sleep?
That's a very good question. So benzos seem to flatten out your sleep curve. So where I showed you those, the two top ends of sleeps, in other words, your slow wave sleep and your REM sleep, you have less of those stages. So you have a more sort of stage 2 type profile of sleep. The Z-class drugs are meant to be a little bit better in that sleep profile.
Thank you very much.
So there's a question from Mike. Why do your eyes move rapidly during REM sleep? So that's sort of associated, I think somebody who knows the physiology, perhaps Dale can answer that question better than I can, but it's linked to the brain regions which are activated. So the reticular activating system is very important for the generation of REM sleep, and that involves the activation of your eyes, essentially, and that's why your eyes move. That's kind of my slightly imprecise neurobiological understanding.
Hi. So when you have that Sunday afternoon nap after a big meal, I find if you sleep too long, you wake up feeling awful. You feel sort of, very dozy for a while. Whereas if you just have a short little, like almost just to lie on the bed for 20 minutes or so, then you wake up feeling fresh. Why is it that you feel, well, I certainly do feel, I feel terrible. So I try to avoid a long afternoon nap.
There's often that kind of sleep inertia, and that comes with a very bad feeling if you sleep for a long time. I have to say my personal experience has been different, that if I get like a solid hour sleep, I might be groggy, say, for the first 5 or 10 minutes, but then I'm on sort of full power after that. So there's quite a lot of individual variation, but it is sort of like a sleep inertia that sets in if you have a longer nap, which is not ideal.
Thank you.
Amanda.
Thank you so much. My question is, can you catch up on lost sleep? If you have been deprived from sleep over a period of years, working very hard, long hours, and then you retire and now you've got more time to sleep. Is that possible?
Mm-hmm.
Thank you.
I think, there are always costs, and particularly over long periods of time, there can be costs to sleep deprivation, which we can't always catch up. And they're often subtle, they're not big things, like you've suddenly been launched off into a dementia or anything like that. But these things pile up, and they often go hand in hand with other chronic conditions. When you're sleep deprived for long periods of time, your hormonal system goes out of sync, so your regulation of satiety and of hunger can be dysregulated, so you tend to be more hungry, less full, and have more tendency to eat sweet and fatty foods. So these sorts of things go hand in hand together, and that can lead to, for example, obesity, cardiac disease, and so that's where you start to see kind of long-term damage from sleep deprivation. Also, there's the risk factor for Alzheimer's disease, that kind of thing. So it does build up. It's like anything, you abuse your body over time, you'll see the scars or the results of that. Whether you can reverse that, certainly engaging in a more healthy lifestyle, I think can reverse those kinds of things to some extent, but it depends how far you've gone down that rabbit hole, I think. I see Dell had her hand up as well. Did you perhaps want to add something to that?
Yes, thanks. I was just not sure if you wanted me to add to the rapid eye movement in, why the eyes are moving in REM sleep, because I certainly can if that's,
yes,
there we are. But you
please
asked,
do.
You're quite right there. It is linked with sort of more neuronal activity in that phase of sleep, which is attributed. They actually did a horribly invasive study where they put deep electrodes into epileptic patients' brains to see exactly what was going on, and the rapid eye movements that we observe with in REM sleep are linked with a person scanning images that had been shown to them. And so it was, they published this in Nature Communications, where they suggest that the rapid eye movements is every time the eye flicks, it's moving from seen, in inverted commas, to seen in your dream state. So that seems to be why that's taking place.
So I see Sandra's got a comment here. She says, if you wake up in the middle of the night for an hour or so, do you pick up where you left off when you go back to sleep, or do you start at your early stage again? So that's a very good question. You may or may not pick up exactly where you left off. So in other words, if you were in REM sleep, you may not go immediately back into REM sleep, but more or less you'll probably start in a similar phase of sleep. So if it's in the second half of the night, it's unlikely, unless you're very sleep deprived, for example, that you'll then go into a lot of slow wave sleep. You'll rather go into the pattern of oscillating between REM and stage 2 sleep. So there is a tendency to go back to a similar pattern, although it may not be precisely where you left off, that kind of thing. And then Taylor says, I have really intense and vivid dreams where I can see and pick up on emotions in the room, and I'm often in control of my dreams. Could you tell me more about what stage does that happen, and why do some of us have such intense and vivid dreams? So typically, I mean, those are probably REM related dreams. Often, I suppose it's a little bit more anecdotal, but I've heard it reported by several people. The dreams where you have, so there's a phenomenon of lucid dreaming where you have more control of your dreams, and some people even practice, engage in that practice to try kind of influence the kinds of experiences that they have in dreaming as a kind of proxy for emotion regulation and having some kind of mastery over emotions in general. But it does also happen spontaneously, and I think it's often towards waking when you have sort of a bit more executive control over the experiences. It's a sort of more slightly awake, more slightly dream in sleep phase, and so you have these moments where you are more lucid and are able to kind of sort of control your dreams. The vividness of it is probably related to the fact that you can remember those dreams more, because we dream throughout the night, but we only remember, some of us are very good at recalling dreams and others less so, but you typically remember dreams more closer to waking and forget those dreams and don't remember dreams that you've had in the deep parts of sleep. So it's likely, or at least one hypothesis, is that you're not entirely asleep, that there's little awakenings which help you remember your dreams. And REM dreams are often very emotional and very vivid. So that feeling that you're having these vivid and emotional dreams is because you have these little moments of awakening where you can actually hold on to the dreaming process. From Jan, there's a question, how do you know that we dream throughout the night? Because researchers have subjected their poor research participants to protocols where they wake them up every single time they go into REM sleep, and between 80 and 90% of those awakenings yield a dream. So you think you're not dreaming. For those of, I count myself one of those low dream recallers, hardly ever remember any of my dreams, but it's not because I'm not having any dreams, I just simply don't remember them. But if you were to wake me up every time I went into REM sleep, I'd probably remember a dream 80 to 90% of the time.
Thank you very, very much, Gosia, and thank you for the discussion, everybody. That always makes the lecture very interesting and adds richness. Thank you very, very much, and we will see everybody tomorrow for the next installment.